Welcome to my YouTube channel. Today we are discuss very important topic. It is electrophile. It is shortly represented by E plus. That means the deficient species. Now we are discuss a few characteristics regarding electrophile. Number one, it is electron deficient species. Number two, positive charge or neutral species which have vacant orbital. That means the electrophile, it may be positively charged or sometime it is also neutral species. Both have vacant orbital. It is the main characteristic of electrophile. Let us we discuss few example of electrophile. At first I write here cations. CH3 plus, CH3, CH2 plus, H plus, NO2 plus, NO plus, SO3H plus, R C double bond O plus, Cl plus, Br plus, etc. These all are electron deficient species. This plus charge contains, it is a vacant orbital and it has tendency to accept the electron density. That's why these all are the example of electrophile containing positive charge. But some example I write here: NH4 plus, H3O plus, also group 1 and group 2 cations. Group 1 cations like lithium, sodium, potassium, and group 2 beryllium, magnesium, calcium. These two positively charged metal, plus 1 and plus 2 respectively, have no tendency to accept electron density, just like NH4 and H3 plus also. This NH4 and H3 plus does not work as electrophile because they have complete octet. That means in NH4 plus ion and H3 plus ion, it's looking like positively charged, but it has no vacant orbital, so it has no tendency to accept electron density. That means it is the exceptional case. It has no electrophilic in nature. Okay. Next, some I write here few example. There is no charge, but it is also behaves as a electrophile, and it is called neutral electrophile. I write here few example: AlCl3, that means aluminum trichloride, BF3, BCl3, BH3, SiCl4, PCl3, SnCl2, SnCl4, and SbCl5. These all the example of electrophile, just like AlCl3, AlCl3, Cl, Cl, Cl. It is sp2 hybridized, triangular planar geometry, but it has vacant 1p orbital. That's why it can behave as a electrophile. I write here all Lewis acids are electrophile. What is Lewis acid? We know the species which have tendency to accept electron density due to the presence of its vacant orbital. It is called Lewis acid. So all Lewis acid has tendency to accept electron density. That means the all Lewis acids are electrophile. Some polar pi bond. Polar means due to the presence of dipole moments. That means mu not equal to 0. It is called polar component. And polar pi bond. Few example I write here. Carbon dioxide. It is sp hybridized linear geometry. Sulfur trioxide sp2 hybridized triangular planar geometry, and aldehyde, ketone. These all are the example of electrophile, and it is called polar pi bond. It is S double bond O bond, here C double bond O. Due to the difference in electronegativity, oxygen can attract electron density towards itself. That's why it can form delta negative charge. And during the formation of delta negative charge, here carbon also delta positive charge. That means it is deficient species. Here the star carbon is electron deficient. In similar manner, here sulfur also deficient species. Here carbon also deficient species for the aldehyde. Here ketone, this carbon also electron deficient species. So these all are the example of polar pi bond. I write here one example, just looking like it is the one type of ketone, RC double bond R, and it can exist sometime in this manner, RC single bond R single bond O minus this is plus. That means this carbon is the deficient species. So as per the electrophile concept, this is electrophile. That means it is electron deficient. I write here deficient. Deficient means this carbon has tendency to accept electron density. It is also electron, and this electron donate the electron density in deficient this carbon. Today we have discussed electrophile topic. Thank you.